So on this handout, we're first going to review that the word roots, zeros, x-intercepts, solutions all mean the same thing. They mean answers. On this section, they're going to ask you to solve each equation and also state the number and type of roots. So we already know how to solve equations, especially when we have all these different factoring skills built up in our toolbox, right? So what is the first type of factoring we could do on this equation? GCF. Pull out that x. What do we have left? We have an x to the fourth minus 81 with no x. Now, inside the parentheses, we have a difference of two perfect square terms, right? Now, you guys might not see that, but x to the fourth, you could actually take the square root of x to the fourth. That would just be taking 4 and dividing it by 2. And you could actually take the square root of 81, which is 9. So what you really have is x squared with a 9, x squared with a 9. But if it's not a trinomial, that means that the middle term had to eliminate. One has to be plus, one has to be minus. Of course, there's an x in front. Now, you got to continue factoring, though. Or you could split them right now and solve. Do you guys want to factor this one to x plus 3, x minus 3? It's pretty easy, right? Might as well do that. Let's do it. Factor that one to a x plus 3, x minus 3. And of course, nothing else could be factored. Let's just rewrite everything. This is the completely factored form of the above fifth degree binomial equation. So we've factored it, and now that we know that we have something times something times something times something equal to 0, we could split each of those and set them each equal to 0. So x, that could equal 0, and guess what? That's an answer. X squared plus 9, that could also equal 0. Right there, we're going to have to do some work. Subtract 9 on both sides. You're going to end up with x squared equaling negative 9. And then you're going to square root. You'll get x equals plus or minus, what's the square to negative 9? 3i. So we have two imaginary answers right there. And then we got to continue setting the rest of these guys equal to 0. So we have a x plus 3 that equals 0 and an x minus 3 that equals 0. That's going to give us two answers. X equals negative 3 and also x equals positive 3. So we really did have a total of 5 answers. 3 of them are real, x equals 0, x equals negative 3, positive 3, and 2 of them are imaginary, the plus 3i and also the negative 3i. So let's just write that down. In addition to our answers, there was 3 real and 2 imaginary. Any questions? So we're good with this, right? We got it. We're done. No, I'm just kidding. We're not. See, on this one, what if I told you to solve this guy? X to the fourth minus x to the third minus x squared. You can't do it. Why not? Well, because you try pelling out a GCF, you can't do it. Even if you think about factoring by grouping, it doesn't work. One's a trinomial, one's a binomial. It's not going to work. So what do we do? What we do is use a certain truth, a theorem in math. It's called the rational zero theorem. Okay? The rational zero theorem allows you to create a list of possible answers. And you could test those answers with synthetic substitution. You guys remember when you plug it in? If you have an answer, if you have a real answer and you plug it in, what are you supposed to get as a remainder? 0. That's right. So it says right here, if your remainder is 0, you found the solution. The remaining row of numbers gives you the depressed polynomial that you could attempt to continue to factor, or you could even continue to plug in with those remaining numbers. And we'll get to examples of this right now. So you guys are probably thinking, how do I get this list of possible answers that we could start testing? Well, the list of possible answers comes from the fraction p over r and a plus or minus, where p represents all the factors of the constant and r represents all the factors of the leading coefficient. So are we able to identify the constant and are we able to identify the leading coefficient on this one above? What is the constant up there? Negative 2. So let's write down the rational root theorem, plus or minus p over r, okay? And it's all the factors, Okay, so p, we said, was the constant over r, which is the leading coefficient. So it's really nice when your leading coefficient is 1, because how could I get to over 1, right? How could I get negative 2 over 1? There's only a couple of ways to get negative 2 over 1, which is negative 2. How could you get negative 2? Well, it's either 1 times 2, negative 1 times negative 2. It doesn't matter if it's plus or minus, right? There's a plus or minus in front of it. It doesn't matter if it's a positive or negative. But that's the only possible ways of getting the constant over the leading coefficient. So this is your list of possible answers, believe it or not. So if we were totally clueless, we could make this list and we could just start plugging in one of these numbers, see which one works. So let's start with 1. Let's plug in this first value of 1 right into the box. Let's do our coefficient list. The coefficient of x to the 4th is 1. The coefficient of x to the 3rd is negative 1. The coefficient of x squared is negative 1. The coefficient of x is negative 1. The coefficient, actually the constant at the very end is negative 2. Okay, so as we go down, we combine. 1 plus nothing is 1. As we go up, we multiply. 1 times 1 is 1. As we go down, we combine. Negative 1 and positive 1 is 0. As we go up, we multiply. 1 times 0 is 0. As we go down, we combine. Negative 1 and 0 is negative 1. As we go up, we multiply. 1 times negative 1 is negative 1. As we go down, we combine. Negative 1 times negative 1 is, or negative 1 plus negative 1 is negative 2. And as we go up, we multiply. 1 times negative 2 is negative 2. Boo. Boo. Why boo? Because it gives us negative 4, not 0. So what do we know about the possible answer 1? It doesn't work. Scratch that out. That sucks. All right, let's try another one. Okay, let's try another one. Let's go with negative 1. Okay, so let's do this. Let's do it again. Put a negative 1 right in there. So I'm going to test this one now. Again, same coefficients. Let's try to do this quickly. 1 comes down. As you go up, you multiply. So negative 1 times 1 is negative 1. As you go down, you combine. Negative 1 and negative 1, that's negative 2. As you go up, you multiply. Negative 1 times negative 2 is positive 2. As you go down, you combine. Negative 1 and 2 is 1. As you go up, you multiply. Negative 1 times 1 is negative 1. As you go down, you combine. That's a negative 2. As you go up, you multiply. That's positive 2. And finally, we found an answer because the remainder is 0. So what could we say? Guys, x equals negative 1. We got it. Oh, we have one of them. What? How many possible answers could we have on this guy? 4. We could have 4, right? Some of them might repeat. We might end up with 2 imaginary, right? But we could have a total of 4, okay? So we barely have 1. Let's keep going. Would you guys like to try to write this as a depressed polynomial and then try to factor it with our factoring methods, or continue testing? Continue testing? All right, which other answer would you like to test? 2? Okay, so we could test the 2 right now with those remaining coefficients of our new depressed polynomial. So you don't have to go back to the original. You could use this, it'll be shorter, right? So let's try it. Let's put a 1, a negative 2, a 1, a negative 2. And let's go down. 1 plus 0 is 1. 2 times 1 is 2. Negative 2 and 2 is 0. 2 times 0 is 0. 1 plus 0 is 1. And 2 times 1 is 2. Yay! Heck yeah, we got lucky. We got another answer. So x also equals positive 2. So we have negative 1 and positive 2 so far. Should we test another? You know, right here, you might as well factor. You might as well factor because it's really easy. What's my depressed polynomial? Somebody read it to me. 1x squared plus 0x plus 1, right? Because remember, you keep going down each time you do this. You started with the original power of 4. So the original one was power 4. This became power 3. And then we used the depressed polynomial. And this is now power of 2. I mean, power 2. Power 2 here. or if you're lost, let's say you did too much work and you're kind of lost, this one has to be the constant, this one has to be x, this one has to be x squared. So from your constant, you'll be able to identify what powers you have. Okay? Anyhow.
Why did you use the same numbers for the last one?
Because you could have gone to the original, but there's more numbers. But since it worked, you could use the depressed polynomial numbers. Because you got a zero. Because you know it works. So, I have this. This must be a factor of it. But I don't want it in factored form. I want solutions. So why not just set it equal to 0 and actually solve? Right? So I'm going to have x squared plus 1 equals 0. You're going to have x squared equals negative 1 if you subtract 1 on both sides. If you square root and square root, you're going to get x equals plus or minus what? I. Ladies and gentlemen, we do have 4 answers. 2 of them are imaginary and 2 of them are real. X equals negative 1, positive 2, and x equals plus or minus I. Just to let you know, you could have, from this point, you could have written this as a depressed polynomial, x to the 4th minus 2x squared plus x minus 2, and you could have done factoring by grouping. Anyway, let's try another one. This one's a little more challenging because we have an 8 as the constant. So what are all the possible answers using the rational zero theorem or rational root theorem? Okay, so give me one possible answer. It could be 1. It could be negative 1. It could be what? Negative 2, positive 2. Could be what? 4 and negative 4. So we have all these possible answers. Now, where did I get this possible answer? Remember, all these possible answers, it's all the factors of the 8 over 1. So it's all the factors of 8, and it doesn't matter if it's positive 8 or negative 8. So what times what is 8? That's good I said that because there's actually an 8 and a negative 8 that could also be answers, right? Because a factor of 8 is 1 times 8, or negative 1 times negative 8. So we have a long list. Let's start testing. Let's test the number 1. Let's plug in a 1 into the box. Let's do the list of the coefficients. As you go down, you combine. 1 plus 0 is 1. As you go up, you multiply. 1 times 1 is 1. 4 plus 1 is 5. 1 times 5 is 5. Negative 3 plus 5 is 2. 1 times 2 is 2. That's not going to work because that's going to give me negative 12. That's not going to give me the remainder 0. So 1 didn't work. Let's try another one. Should we try negative 1? I always try 1. You guys want to try 4? Okay, let's try 4. So in the box, we're going to put 4. So 1 didn't work. Let's try 4 now. And maybe to not get confused, we could do this. So we could put a line through that top one. We know that didn't work. All right, so as you go down, combine. 1 plus 0 is 1. As you go up, multiply. 4 times 1 is 4. As you go down, 4 plus 4 is 8. 4 times 8 is 32. And then 32... I don't know if that's going to work. Negative 4? Okay, so how about this? I didn't do much work. Let me change this to a negative. Let me make this a negative 4 right here, which means negative 4 times 1 would give me a negative 4 up here. And then 4 minus 4 would be 0. That's nicer than 8. And then negative 4 times 0 would be 0 up here. That's nicer than 32. And negative 3 and 0 is negative 3. And negative 4 times negative 3 is positive 12. Is that going to work? Negative 2? Sure it does. Because negative 4 times negative 2 is positive 8. 0. Finally, happy face. Yay. So we know that positive 4 didn't work. Negative 4 did work. So we have an answer. X equals negative 4. Now we could, at this point, try to factor this, but I don't think this would work. Let's just test another one. Give me another one to test.
Why would it work?
Well, see, if I did a depressed polynomial, I'd have a x to the 3rd, right? x to the third minus 3x minus 2. It's not necessarily a quadratic. You can't even change it to a quadratic. So let's try a different answer. Somebody said negative 2. Or you guys want to try negative 1? We've never even tried negative 1. Yay? Nay?
Sure.
Negative 1. Set it up. But this time, instead of going with the original coefficients, I want to go with these depressed coefficients. It'll make it a little shorter, a little quicker. 1, 0, negative 3, negative 2. So as you go down, you combine. 1 plus 0 is 1. As you go up, you multiply. Negative 1 times 1 is negative 1. 0 and negative 1 is negative 1. Negative 1 times negative 1 is positive 1. Negative 3 combined with 1 is negative 2. Negative 1 times negative 2 is positive 2. Thank goodness it works. Right? It works. Another happy face. So we also know that x doesn't only equal negative 4, it also equals negative 1. So now at this point, instead of continuing to test, since this is now a quadratic, I know quadratics. We factored all kinds of quadratics. Let's write it as a depressed polynomial. It's a quadratic. X to the second minus 1x minus 2, that equals 0, which means we could factor and then split it and solve. So what times what is negative 2, that if you combine together is the middle value, negative 1. Negative 2 times positive 1. Which means when I split them, x minus 2 equals 0 and x plus 1 equals 0. I want to get my two other answers. What are the two other answers? X equals 2. X equals negative 1. So, ladies and gentlemen, we have our four answers. X equals negative 4, negative 1, 2, and negative 1. There's duplicity on the answer on negative 1. So if you write it 2 times, it's fine. Actually, some teachers want you to write the negative 1 2 times. On the answers, they might even write them 2 times. On my test, if you happen to just write it once, that's okay with me. All right. So you don't have to write x equals negative 1, x equals negative 1. But maybe on a multiple choice test, they do. I don't know. Alternative to a rational zero theorem. What's the alternative? Instead of doing the multiples of the c over the constant over the leading coefficient, simply graph it on your graphing calculator. So if I type in the function y equals x cubed plus 6x plus 20, I just type this in, and all I need to know is where it crosses the x-axis. As you can see, it crosses where? Negative 2. So with the Desmos app, if they let you use it on the final exam, it's awesome because you know you're going to have x equals negative 2 as an answer just from the app, right? So if you know an answer, then you could plug in that answer into synthetic substitution. What would my coefficients be? I have a 1 on the x to the third. What's the next coefficient? 0. Thank you. I almost put 6, but there is no x squared, so you have to represent that x squared with the 0, saying that there is no x squared. And then you have the 6, and then you have the 20. So if we do this, 1 comes down, negative 2 times 1 is negative 2, 0 and negative 2 is negative 2, negative 2 times negative 2 is positive 4, 6 plus 4 is 10, that's negative 20. Of course it works. I already knew it works because I saw the solution on the graphing calculator, right? But now we have a quadratic trinomial that we could actually solve. Let me write my depressed quadratic trinomial. X squared minus 2x plus 10. Ladies and gentlemen, you cannot factor that. If you try to do what times what is 10, that if you add together is negative 2, you can't do it. Which means we're going to have to rely on the quadratic formula, where our a value is 1, our b value is negative 2, and our c value is 10. So when you use the quadratic formula, you have to rewrite it with parentheses. So let's plug in our b value of negative 2, our a value of 1, and our c value of 10. And let's do this math. You start with your discriminant, which is the value inside the root. What is negative 2 squared? 4. And what's 4 times 1 times 10? 40. 4 times 1 times 10 is 40. So I really have 4 take away 40. What's 4 take away 40? So inside the root we have a negative 36. Outside we have the positive 2 plus or minus that square root of negative 36, all divided by 2. So what's the square root of negative 36? It's 6i, right?
Yeah. On the,
So just to reiterate, guys, negative 36, when you square root it, the negative sign comes out as an I, and then the square root of 36 is 6. So you have I times 6, which is 6i. So what I really have is 2 plus or minus 6i, all divided by 2, which means I could separate my division of 2 to each of those. 2 divided by 2 is 1. 6i divided by 2 is 3i. Or you could reduce them all by 2. You're going to get 1 plus or minus 3i. So there are your other two answers. So what do we have here? We have a total of 3 answers. 1 real, which is negative 2, and 2 imaginary, which is 1 plus 3i and 1 minus 3i. Let's move on to this final, most important part. By the way, let's just read this theorem. It's called the complex conjugate theorem. If they tell you that any imaginary value is a solution, then you know that its complex conjugate is also a solution. So they want us to write a polynomial function given the answers. Do you understand that? They want us to write the function that has these answers. So where do you think the answer negative 5 came from? Let me actually write that answer down. X equals negative 5. Everybody write that down, please. Where did that answer come from? It came from a binomial that was set equal to 0. So I'm going to kind of add 5 to get that binomial that was originally set equal to 0 when I split and solve with 0 product property. Does that make sense? So what I'm trying to get at here is the answer negative 5 came from this binomial x plus 5 that was set equal to 0. Let's also write down this answer over here, x equals positive 3i. That must have come from subtracting 3i from the binomial x minus 3i equaling 0. That's where that answer came from. And we just said the theorem of complex conjugate, which is if this is an answer, then you also have negative 3i as an answer. That's what the theorem says. If I is an answer, then negative I is an answer. If negative 7i is an answer, then positive 7i is an answer. Do you get the theorem? Okay. So I also need to write that x could also equal negative 3i, which means that that binomial that produced it would be x plus 3i equals 0. So I really do have 3 binomials that are all equal to 0 that gave me these 3 answers. So what I'm doing is working this problem backwards. I want to put all these 3 binomials together as multiplication. So I have the x plus 5 times x minus 3 times x minus 3i, this is a 3i, and x plus 3i. Let me put this in red to stay consistent here. Anyway, we need to distribute all these things to be able to get our final polynomial that gave us those answers. Please begin with your imaginary binomials, because they are conjugates of each other, which means that the imaginaries disappear. Let me show you. X times x is x squared. X times 3i is 3i with an x. Negative 3i times x is a negative 3i with an x, which means that they cancel out, right? And then negative 3i times positive 3i. Negative 3 times positive 3 is negative 9. But I times I is I squared. And we should know that the I squared is really a negative 1. So these guys canceled out. You have x squared. What is a negative 9 times a negative 1? Positive 9. So you see how those two disgusting imaginary binomials, when you distribute them, it becomes a nice looking binomial? And we still have this x plus 5 out here in the front. So let's distribute to get to our final polynomial that gave us those answers to start with. So we have x times x squared, that's x to the third. X times 9, that's 9x. 5 times x squared, that's a positive 5x squared. 5 times 9, that's plus 45. Write it in standard form, and you will have the function. You could put it f of x, you could put y, you could put g of x, whatever you want. X to the third plus 5x squared plus 9x plus 45. That is your equation that produces those answers. Negative 5 and also 3i and also negative 3i. Now, on your worksheet, you have different example number 2. Please change it to this one. The reason why, go ahead and change yours to this one. The reason why is that second example that you have in your worksheet, it did not come out on the final, so I'm not going to go over it. These are the types that come out on the final exam. Might as well stick to these. So where did these answers come from? First of all, where did the binomial, or where did the answer -2 come from? From the answer, from the binomial x plus 2 being set equal to 0. Where did the answer x equals 1 come from? From the binomial x minus 1. Where did the binomial, where did the answer 3i come from? From the binomial what? X minus 3i, which means that we also have a -3i as an answer. And where would this answer come from? X plus 3i. I'm just skipping that part with the 0, right? We need to show that. And now let's distribute. Are you going to start with the red binomials or the blue ones? Blue ones. You have to. Why? Because the imaginaries will disappear. If they don't disappear, you did something wrong. X times x, x squared. X times 3i, that's a 3i with an x. -3i times x is a -3i with an x. -3i times +3i. A -3 times a +3 is a -9. An I times I is an I squared. I squared we already know is -1. We know that these middle values cancel out. Your binomial will be x squared with what? Plus 9. Why? Because -9 times a -1 is a +9. So there's our nice, beautiful binomial that used to be two ugly, complex binomials. So now we need to distribute it through with the other ones. It gets kind of tedious, but let's multiply x minus 1 into this x squared plus 9. So what's x times x squared? That's x to the third. What's x times 9? That's 9x. What's -1 times x squared? That's a -x squared. What's -1 times 9? That's -9. Could we combine any of those terms? No, we cannot. We could put it in order though. X to the third minus x squared, x squared plus 9x minus, man, if somebody wants to give me a Christmas present, buy me a fly swatter because these flies are driving me crazy. Okay, so we have that. We also need to bring down the x plus 2 and finally distribute there. This is ugly. We have x times x to the third, that's x to the fourth. X times that, it's going to be negative x to the third. X times that, it's going to be plus 9x squared. X times that, it's going to be a negative 9x. Now, maybe it'd be better to distribute this way. Look, watch. 2 times x cubed is 2x cubed. I want to put that 2x cubed right below the other x cubed. It'll help me combine later. 2 times -x squared is -2x squared. I'm going to write it. You don't have to do that. But, I mean, it's nicer because you could combine them easier. And then 2 times 9x is a positive 18x. And 2 times -9 is -18. So now we could combine them to get our final polynomial fourth degree answer. X to the fourth plus 1x to the third plus 7x squared plus 9x minus 18. That's your f of x function that gave you those 4 different answers. Which 4 different answers? The -2, the 1, the 3i, and the -3i. There will be at least one of these on the final, so please don't blow it off. There's going to be 2 of these on the test. Guys, your solution, can't even speak right now. Yes, I just farted. Okay, we're going to be doing worksheet 5.7. It's on the back side of your notes, but it's only the solutions, right? I want you to first of all, change your assignment to this. This is an easier assignment than what you have. I want you to do 2, 3, 4, 5, 6, and then skip to 11 through 16, and then just 17 and just 19. Okay? I need you to copy those down into your notebook and do all your work in your notebook. Okay, that's it, guys. Tomorrow we review this stuff and review for the test. And then next week we review for the final.